Hi, this is Open Up Resources, Algebra 1, Unit 1, Lesson 10. I know, what do you know? So today we're going to identify the type of sequence given in any representation, and we're going to find efficient strategies for representing the sequences with tables, graphs, equations, explicit and recursive. So basically, they are going to give us some piece of information. So there's some information that we're going to have. We have to figure out what else we know from it. Now, different representations are a table, graph, the two types of equations. We might be able to find a constant ratio or a constant difference, any terms that might be missing. We can tell if it's arithmetic or geometric. We can even come up with a story context. So we'd like to try to find as many as possible, but we need to have at least 4 of these. So let's go ahead and see what we've got to start with. First one, excuse me. I know the first 5 terms of the sequence are 0, -6, -12, etc. Okay, so we already have terms. We could also add some more terms here. So actually, before I add terms, I need to know what's going on, right? Is this arithmetic or geometric? So let's start with, actually, I'll just do here. I noticed here it's a -6. And I can't actually multiply a 0 to get anything, so it must be a -6. So my common difference is -6. That means this is arithmetic. And then I need to come up with an equation. So if we start with, I'm going to go ahead and let's do recursive. So I'm going to just do my bracket. So my first term is a 0. And then go ahead and just do that again. So we know this is all part of the recursive. My f of n equals f of n minus 1. And I know I'm subtracting 6 each time. All right. So there's my recursive. Let's do an explicit. F of n equals, my starting term is 0. And so I wouldn't actually have to put that, but that's okay. I'm going to go ahead and do -6. And since this is my second term, I need to do n minus 1. And so I technically, since 0 is not really anything, 0 minus anything leaves me that number, -6. We can actually take the 0 off. So a table, let's go ahead and just do a table just so you can see how this works. We have our first term is 0. Second term is -6. Third term, -12. Fourth term, -18. And fifth term, -24. We want to find missing terms. We can go another -6, and that'd be -30. And we can even do 7 would be a -36. So we could keep going on that if we want to. So we found some missing terms. We made a table, found all those pieces. I'm not going to worry about a graph or a story context. On this one, we have quite a bit of information we figured out. Okay, number 2, I know that a sequence where f of 1 equals 5 and the constant ratio between the terms is 3. So it is a constant ratio. Let's go ahead and do purple for this. Constant ratio, which means it's a times 3. So I was going to, let me undo that. So if I'm going to do my recursive, it tells me my f of 1 equals 5. And my next term is my previous times 3, which means my explicit equation is I'm starting with 5, and I'm going to times 3 repeatedly, but I started with the first term, so it's an n minus 1. So that makes this one a geometric, and a table would then be 1 is 5, 5 times 3 is 15, 15 times 3 is 45, and 45 times 3, pull out my calculator for this one, 45 times 3 is 135. This would be a 135. So I found some missing terms over here. So I found 3 terms. I made a table. I have both types in my equations. It's a geometric sequence. I think I've done quite a bit on here. I'm not going to, again, worry about, it's hard to do the graphs on here, so I'm not going to do those unless I need to. A story context. You could say I started with $5 and I know that every month it's going to triple in value with this investment that I've done. And so there'd be a story context to go with it. All right, 3. Ooh, here we're given a graph. So let's see here. Can we tell if it's arithmetic or geometric? Looks arithmetic to me. I'm going to go ahead and type this one because that's a little easier to write on here. It's arithmetic. And it looks like that it's starting at, I'm trying to tell my lines here. 1, 2, 3, 4. So it's 1 line each. And so from going from here to, I'm trying to figure out where it's kind of on a line and crossroads here. So for number 3, it looks like my, it's negative, and kind of looks like that it's going down from 11. So my slope, my y is 11 to 7. So that's 4 over, that's my rise, and my run is from 0 to 6, which is 6. All right, so it looks like my slope is a negative 4, 6. So it's right 6, but it's down 4. So rise over run would be 4, 6. So let me go back to my text box here. Oh, there we go. So it's arithmetic, and the common difference nope. And this one. Okay. Common. Don't know why it's not doing it in common difference is negative 2/3. Because I'm going to just simplify that. 4/6 is the same thing as 2/3. All right. Next, can we come up with our equations? I bet we can. You know what? Let's do a table first. Just because, why not, right? So, the 0 is 11. If we're taking away 2/3, 1, 2, 3. So this would be 10 and 1/3, right? And then this would be 9 and 2/3. And then this one would just be 9. Okay, so I've come up with kind of my sequence on here. And actually, we'll just go ahead and do a couple more. It's always good to do. Because we said 6 was right at 7. So this would be 8 and 1/3. 7 and 2/3, and so on. All right, so f of 0, that's our first term, is at 11. And then f of n equals f of n minus 1. And we take away 2/3. And then our explicit, we start with 11 and we subtract 2/3 n times, right? So multiply in there. 2/3, I'm going to write that slightly. I don't want you to get confused as to that being a exponent. So 2/3 n, because it's the 0 term, so I don't have to subtract anything. And 1, 2, 3, 1, 2, 3, 4. I've got 5 representations. We're good. All right. I know that the explicit equation for the sequence is f of n equals -10 times 3 to the n minus 1. Well, it is a times. So let's just go ahead and jump to blue this time. We know that this is a geometric, and we have a common ratio is what we are multiplying over and over, which in this case it's a 3. If we were to do a table for this one, I'm going to do it off to the side here. Start with my blue. Okay, so if I put in a 0, we better start with a 1 since we have negative. It's a -1, so let's start with a 1. So if I start with 1, 1 minus 1 is 0. 3 to the 0 power is 1. -10 times 1 is -10. 2, 3, 4. Now I could keep plugging in the numbers and say 2 minus 1 is 1. 3 to the first power is 3. -3. -10 times 3 is -30. Since I know the common ratio is 3, I can just multiply my answers, my outputs, by 3. So that makes this -90, -270. Ooh, I don't know what 270 times 3 is. Let's do this one quick. 270 times 3, 810. All right, so this one is an 810. All right, so now with I've got my explicit, so now I'd better come up with my, wow, that was lousy, my recursive. Oh, right here. F of 1, my first term I have, is a -10. That's what I started with. And then f of n equals f of n minus 1. And I know it's a times 3. Over and over. So there is 1, 2, 3, 4 different things expressing for it. Basically just missing the graph. And I said I'm going to avoid those since it's not easy to do that on the computers. All right, number 5. I know the recursive equation for the sequence is f of 1 equals -12. And then each time I'm going to add 4. So I'm going to go ahead and just do my table first. My first one is -12. And then if I add 4 every time, -12 plus 4 is -8, plus 4, plus 4. I'm going to do a 5th one just so I get a 5 on here. Okay, so it's a plus 4, which tells me that this is arithmetic. My common is 4. And then I just need an explicit. Let's jump to an explicit, because I found some missing terms. And I'm not going to worry about the graph. So f of n equals, what did I start with? I started with a -12. And then I'm adding 4 over and over. But it's my first term, so I need an n minus 1. All right. That one looks good. I think we only got a couple more here. Number 6. I know that the sequence models the value of a car originally cost $26,500, but loses 10% of its value each year. Let's start with a table on this guy. So The models originally, that's a 0. 26,500. So after the first year, it loses 10%. Well, if it loses 10%, what percentage is it keeping? Well, if you start with 100 and you lose 10, you're down to 90%. So we are going to times 0.9 each time on here. So 26,500 times 0.9, 23,850. So this is a 23,850. The second year, let's just go 3 years on here. Let's times our last one by 0.9. 21,465. 465. And one more time. 0.9. 19. We're just going to round to the 31. 318. 19. 318. Actually, round up to 319. It's just a 0.5. It's the last one we're doing. We won't go too far into decimals. All right, there we go. Okay, so what do I know? Well, I'm multiplying. So this is geometric. Common ratio is 0.9. That's losing its value each year. My recursive f of 0, my original amount is 26,500. And what I'm doing each time is a times 0.9. Use the x this time since I have some dots. And then my explicit is going to be f of n equals my starting amount. 5 times 0.9, and it's to the n because I'm starting with an original. So each year I put on there, it is down. So 1, 2, 3, 4, 5. So here is a story context. They gave us the story context this time, and we put all the rest of the stuff. Next, 7. I know for the first term, the first term of the sequence is -2, and the fifth term is -1/8. So if I do that, that's kind of like the ones we've been working on, right? Now, here's the catch with this one, though. So we don't know a whole lot. I can make a table. 1, 2, 3, 4, 5, -2, -1/8. So, do I know if this is arithmetic or geometric? I don't. So if we say this is arithmetic, I'm going to do this in green. Arithmetic. Common difference is, what would the common difference have to be? Well, arithmetic. You take your last minus your first, and then you divide by how many you've got, right? So my last one is 1/8. So -1/8 minus a -2, which really means plus positive. So 2 minus 1/8 is 1 7/8. If I take 1 7/8, then and divide it by 1, 2, 3, 4. So 1 7/8. Let's go ahead and make this improper. 15/8 divided by, what did I say? 1, 2, 3, 4. Which is the same thing as 15/8 times 1/4. This is starting to get kind of ugly, isn't it? This one is 15/32. So what is 15 30-seconds? Let's see what this is. 15 divided by 32. Oh, 0.46, 0.27. So we're taking away common differences. A plus, because we're getting bigger, 0.47, basically, these guys. So we found out those guys. And so if we were to do our equations, I'm just actually going to do the explicit because we're going to actually do 2 on here. So, you know what, let me go back. Now I'm just going to do it with my text box. This guy over here. Okay, so I'm going to have f of n equals, my starting term is a -2, and then I'm going to add 0.47 and then n minus 1, right? Because that's my first term on here. Now, what if we said, oh, let's keep that one green. What if we said it was geometric? It had a common ratio. I'm going to go ahead and get out my drawing stuff. And what if I did this in the blue for a geometric? Geometric is I divide out my last one, right, times my first one, because I have -2, 1, 2, 3, 4 times r to the 4th equals -1/8. Well, if I divide by -2, divide by -2, half of -1/8 is 1/16. Positive, double negative there. Well, the 4th root of 16 is 2. So r is 1/2. So over here, my common ratio is actually 1/2. And so then when I figure out that, my f of n equals -2 times 1/2 to the -1. So it really just depends on what we put in there. If I go with the green, -2 plus 0.47, -2 plus, clear. Negative, here we go. -2 negative plus 0.47 is -1.53. So it'd be a -1.53. And then if I add the 0.47, get -1.06. And if I add 0.47, I can do that one again. 0.47 is, oh wait, no, I'm going backwards. I'm thinking plus 0.47, -0.59. And this one is actually a -0.125. So you're just getting a little higher up there with that. So it's really close. All right, but if we did the blue and said it's times a half, well, what's half of -2? -1. What's half of -1? -1/2. What's half of -1/2? -1/4. And what's half of -1/4? -1/8. So you really could have 2 different answers on this one. We can't actually solve it for the final. All right, ready for more? We are not going to bother with, because you're supposed to work with a partner, create your own, and see if you can just try them with different ways. You're doing the I know part, and then have another team solve it. So we're not going to worry about that one right now. Let's do our takeaways. So if you are given a table, what do we know? Well, with the table, we know the first term. The first term of the sequence. What can we find from a table? We can find a common difference or a ratio. Also graph. We create a graph with the points. And we can find our two types of equations, right? Because with that, we can find our recursive and our explicit because we have a first term and then our common difference. All right, if we're given a graph, what do we know? Well, we know our type of sequence, right? We can look at it and say, oh, it's curved, it's geometric, it's, and let's just go ahead and put that on here. Arithmetic equals straight. Geometric equals curved. Okay, so that's what we can tell by just looking at it. What can we find? Well, we could make a table with the points. And then basically everything else from the table. Right? We also found the common difference from that when our last one we used the points to find a slope. May or may not work as well with the geometric. All right, given an explicit equation, what do we know? Being silly on me here. Well, given an explicit, we can find, we know the type of sequence. This is being a little frustrating right now. Okay, type of sequence. First term, right? Because our explicit equation will give us our first term. Common difference or ratio. And then, yeah, that should be it, right? Type of sequence, first term, common difference or common ratio. Go ahead and put these on second since we were doing that before. Okay. And what can you find? We can find a table using substitution and then everything else from the table, right? Tables really are the most useful to us. We can really find everything with the table. Recursive equation. Really, the same thing as our explicit, right? We can figure out our type of sequence by looking at it. It gives us our first term, and then it gives us our common difference ratio. So both of these will give us kind of that piece of information. What can you find? We can find the explicit equation from that. And then we can also make a table by following the recursive pattern. And then everything else on the table. All right, so if you haven't noticed the pattern in here, it seems like the table is really the most useful. But we can find other things by just looking into seeing what we can do. All right, thanks for joining us today, and we'll see you next time.